Hi, I am Dr. Eli Kolberg from Unlimited Robotics. In this video, I will talk about equivalent resistance of series circuits. Suppose we have a conducting wire with whatever length and resistance R1. Now let's connect to it another wire with different length and resistance R2. Since the resistance is in direct relation to the wire length, the resistance of the joint wire will be RT equals R1 plus R2. This is certainly series connection of two wires since they are connected at one end only. Hence, the equivalent resistance of resistors connected in series is the sum of the resistors' resistance. RT equals R1 plus R2 plus R3 plus all other resistors in the circuits. We will now prove the last equation. Next figure presents a circuit with resistors connected in series. We have a source voltage V and resistors R1 to Rn. The same current I flows through each resistor. The voltage drop across each resistor equals to the product of the current and its specific resistance. For example, the voltage drop across R1 is VR1 equals to I times R1. We will mark the equivalent resistance in the circuit with RT. The equivalent resistance replaces all the resistors in the circuit, keeping the same current flowing in the circuit. It means that V equals I times RT. On the other hand, the source voltage equals to the sum of the voltage drops on all of the resistors. V equals VR1 plus VR2 plus VR3 and so on until plus VRn. It is equal to I times R1 plus I times R2 plus I times R3 and so forth. And it also equals to I times, in parentheses, R1 plus R2 plus R3 plus Rn. The left side of the two last equations is equal to V, so it is possible to compare between them. I times RT equals I times, in parentheses, R1 plus R2 plus R3 plus Rn. And if we divide by I the two sides of the equations, we get that RT equals R1 plus R2 plus R3 plus Rn, which is a proof of the equation we saw before. It means that the equivalent resistance of resistors connected in series is the sum of the individual resistors' resistance, meaning RT equals sigma on I of Ri. This is just abbreviation of R1 plus R2 plus Rn. The source voltage equals to the sum of each individual resistor voltage drop in a closed loop series circuit. V equals the sum on I of VRI. Now we'll do an example. In next circuit, R1 equals to 75 ohms, R2 equals to 150 ohms, R3 equals to 220 ohms, and R4 equals to 510 ohms. What is the equivalent resistance of the circuit? Answer. Given all the data, R1 equals 75 ohms, R2 equals 150 ohms, R3 equals 220 ohms, and R4 equals to 510 ohms, then RT equals to the sum of R1 plus R2 plus R3 plus R4. Substituting the values gives that RT equals to 955 ohms. That is for now. Thank you very much for being with me. Hope to see you next one. Bye bye.